This is a great question that aims to test the fundamentals of number properties and LCM in general. So the question wants us to find the number of unordered pair of positive integers such that their LCM is 400. So let's say if we have one pair of numbers and the elements of those pairs are x and y, the LCM of x comma y equals 400, and we have to find different values of x and y that satisfies this particular condition. Now, one thing that the question has already mentioned is we need to find the number of unordered pair by which it x comma y and y comma x are identical. So there is no difference in the order of the elements within that particular pair. Now, before we dive deep into the solution, let's take a moment to quickly prime factorize 400. So 400 can be written as 4 into 10 into 10. 4 has two 2's in it. 10 has one 2, and this 10 has another 2. Total there are 4 2's in 400. In other words, we can say that 2 has a power of 4 in 200, and 5 has a power of 2. Each of the 5 is a part of the 10 that is out. So in a nutshell, we can say that 400 can be represented as 2 raised to the power of 4 and 5 square. Now, before we move forward, let's look at what a LCM is. Now, LCM, as the name suggests, is the lowest common or the least common multiple. It represents the maximum power of the prime numbers whose LCM we are trying to find out. So, for example, if we have 3 into 2 square, as if this is one number, and let's say 2 raised to the power of 8 into 3 cube, this is the second number. The LCM of these two will be the maximum power of the prime factors, right? So in this case 2 has a power of 2, and in this case 2 has a power of 8, so the maximum power is 2 raised to the power of 8, and 3 has a power of 1, and 3 has a power of 3, so the maximum power is 3 raised to the power of 3. This would be the LCM. So in this case, we can say that out of the two numbers in a pair, and let's take x and y as those two numbers, either x or y or both have 2 raised to the power of 4 in its prime factorized form. Similarly, either x or y or both have 5 square in its prime factorized form, right? So the fact that the LCM is 400 tells us that at least one of these two numbers, either x or y, will have a 2 raised to the power of 4, and at least one of these two numbers will have a 5 square in it. Now there could be other powers of 2 as well. You can either have a 2 raised to the power of 0, 2 raised to the power of 1, 2 raised to the power of 2, 2 raised to the power of 3 in either of x or y. And similarly, for the case of 5, you can either have 5 raised to the power of 0, 5 raised to the power of 1, or 5 raised to the power of 2 in uh, either x or y. But then just reiterating that x or y will have 2 raised to the power of 4 and 5 square. Now we'll try to divide this into cases because that will help us visualize this in a bit better manner. Now let's say I have x and I have y. These are the two numbers in this particular pair, and this is the prime box of x and prime box of y. Now in the first case, that is, we will say this is case 1, let's assume that 2 raised to the power of 4 and 5 square is both of these are present in the prime box of any one of these numbers, and because it's an unordered pair, doesn't really matter whether we are taking x or y. So in our case, we'll take that x has 2 raised to the power of 4 and 5 square in it. Now we cannot have any other prime number uh, in this, because of course 4 the LCM is 400. Also, there cannot be any other power of 2 or 5 in it, because these are the maximum power of x and y. So x will only have 2 raised to the power of 4 and 5 raised to the power of 2. So that will be the elements, the power that the elements of x has. However, y can have any one of the power of this of 2 and any one of the power of 5. So this is like all of these possibilities, all of these combinations uh, y can have. Now, out of the available power of 2, there are 5 powers of 2. So y can have any power of 2 between 0 to 4, and it can also have any power of 5 between 0 to 2. So there are 5 powers of 2 and 3 powers of 5. So y can be formed into y can be formed in 5 into 3 ways, that are there are 15 possible values of y. So for example, y can be 2 raised to the power of 0, 5 raised to the power of 0, 2 raised to the power of 0, 5 raised to the power of 1, 2 raised to the power of 0, 5 square, similarly 2 raised to the power of 1, 5 raised to the power of 0, and so on. So like that, we can have 15 possible values of y. So x has a single value. X is only 2 raised to the power of 4 and 5 square, while y has, there are 15 possible values, and the last value will probably be 2 raised to the power of 4. Sorry, not 2 raised to the power of, yes, 2 raised to the power of 4 and 5 raised to the power of 2. So it can have all of these 15 values. Now let's take another case. In this particular case, the prime box of x and the prime box of y does not have both 2 raised to the power of 4 and 5 square. So let's say x has only 2 raised to the power of 4 and y has 5 square. Now, because the maximum powers are not in the same element of the pair, the element can have other powers of, the other prime factors. So for example, x can have a power of 5 raised to the power of 0. It can have a power of 5 raised to the power of 1, but it cannot really have a power of 5 raised to the power of 2, because we have already considered that 5 square in like both 2 raised to the power of 4 and 5 square are a part of x in case 1. So that we cannot really calculate. But as we saw, it can still have 5 raised to the power of 0, 5 raised to the power of 1 in it. It cannot have any other power of 2, because if we add any different power of 2, it will exceed the maximum power of 4. So for example, if x has 2 raised to the power of 4, let's say 5 raised to the power of 1, and if we add another, this is 2 raised to the power of 2, this 2 raised to the power of 4 now becomes 2 raised to the power of 6 and 5 raised to the power of 1. So this is not possible, because the maximum possible value of the power of 2 is 4. Similarly, y cannot have any additional power of 5, but it can have any of the 4 available powers of 2. It cannot have again 2 raised to the power of 4 in it, because the presence of 2 raised to the power of 4 and 5 square in a single number has been taken care in case 1. So for y, we can have 2 raised to the power of 0, 2 raised to the power of 1, 2 raised to the power of 2, and 2 raised to the power of 3. So the number of possible values in in case 2 is 2 into 4 is equals to 8. And just to quickly talk about some of the numbers in this particular case, we can have 2 raised to the power of 4, 5 raised to the power of 1, sorry, 5 raised to the power of 0 in x, and we can have, let's say, 5 square, 2 raised to the power of 0 in y. So, and then there could be other possible combinations. So these are some of the possible combinations that we can have. So in case 1, quickly reiterating, in case 1 we had 15 possible values of one of the number in the pair, and in case 2 we can have 8 possible values of number. So total the number of possible pair is 15 plus 8, that is 23. So there are 23 unordered pair uh, that exists, such that the least common multiple of the elements of the pair will give us 400.